Alright, are we on? Okay. Let's go around back to the front. Well, hello everybody. Welcome back to Paleontologizing. Here right now at the Science Museum of Minnesota, here in St. Paul, Minnesota. I'm just about to go into the main exhibit area, but let me stand out here in front of the Tyrannosaurus first. Right here. Very, very cool. This looks like a cast of probably Amon H5027. Same one at the American Museum of Natural History. But yeah, holy cow. Welcome everybody. And what a beaut, says Bejeweled. Oh, please, you flatter me. No, I'm just kidding. I know you're talking about the dinosaur. Yeah. Welcome everybody to Paleontologizing. If anybody is new to the channel, I'd like to introduce myself real quick. My name is Danny Anduza. I'm a dinosaur paleontologist. And right now, I'm on a great big road trip going all across the United States, visiting different museums, visiting different field sites, talking to other paleontologists, and live streaming whenever I can. Today, I'm in St. Paul, Minnesota, and we're going to be checking out the beautiful Science Museum of Minnesota, or Minnesota Science Museum. Anyway, it's the big science museum here in the Twin Cities area, and it is definitely worth a stop. If you ever happen to be in this part of the world, make sure you stop by here. And check this out, this beautiful Tyrannosaurus cast here. It's pretty neat. Pretty neat. So welcome everybody. Zintaus, Darth Goof, Jody Fish, Lara Croft, Lenina. How are you doing, everybody? It is so great to have you here. And here, let's check this out. This is a cast of the Amon H Tyrannosaurus skull. I recognize this. There's a T-Rex tooth, like I show everybody back in my office. Let's go ahead and try this out. So we've got a lever right here. We're going to have a kinetic demonstration. Pretty cool. Doesn't really go all that far, but it's still pretty neat. Very cool. Well, anyway, yeah. Let's go ahead and go in and see some more dinosaurs and some other extinct critters. We'll see what they've got here in terms of fossils and fossil casts and reproductions of extinct ecosystems and all that stuff. We'll go walk past our gorgeous Tyrannosaurus here. It's just beautiful. Just beautiful. Alright. My intro does it better. Thank you, Zintaus, I guess, if that is a compliment. Alright, I gotta loosen this up a little bit. That's a little better. And let me pull up my QR code so we can go ahead and get in. Alright. It says scan your ticket. So let's go ahead and do that. Come on now. Okay, gotcha. Thank you. Let's try that. There we go. Cool. Do I need anything or just walk in? All right. Pardon? I'm not, no. It's just the main exhibits. Thank you. All right. Normally, of course, I'd be wearing a mask in a museum like this, especially something indoors, but I know there's some people who are hard of hearing, and they like to be able to read my lips, and so I'm forgoing a mask for that purpose. So you're welcome, everybody. Hopefully I don't get sick. But here we are. I've been to this museum one time before and was very, very impressed by it. So we're back. I don't remember this gigantic astronaut, though. I wonder if that's new. That's pretty far out. And right down there, holy cow, it's everybody's favorite giant Asdarchid pterosaur, Quetzalcoatlus. Holy moly, that is neat. And they have a standing one too. Oh, that is going to be so cool. I can't wait to check that out. Let's pull chat up again. There we are. Yeah. And let's see. Very cool. Welcome, Texas Cryptid, Reno, Timber, Smorphosaurus. Welcome, welcome, everybody. Let's go see what there is to see here. This is the scienciest science museum I've ever been to, I think. Which, you know, has its pros and cons. But it's very engaging. And, yeah, I don't know. When I say scienciest, I mean it's the most that, like, takes science as an aesthetic, like, you know, IFL science or something like that. As a scientist, I have kind of mixed feelings about that. We can get into that another time. Right now, we're just here to enjoy the museum and check out the natural history elements, especially. Lots of other stuff here that's not really relevant to our discussion today. All right, we're back. Sorry, everybody. I don't think that was a problem with the equipment or anything. That's a problem with the web portal from Live View. Yeah, somebody said nice backdrop. Thank you. Yeah, that's the issue that I've been having with the black screen at the beginning too. Is that the web portal just isn't really working properly, and it hasn't been since the beginning of this trip. But anyway, yeah. Welcome back, everybody. Hope nobody split during that quick little outage. But welcome back. Made it down onto the bottom floor here. And look at who's behind me right here. Oh, man. Quetzalcoatlus. This is a beautiful model. Holy moly. Check that out, and look at how big it is. I know very frequently when people ask about pterosaurs on my channel, I direct them toward, you know, a photo of a great big Quetzalcoatlus model standing on all fours like this. Well, now you're seeing it in person. And holy cow, is it gigantic. This wasn't here the last time that I visited. This is something pretty special. So there is a standing Quetzalcoatlus. And there is a flying one. Holy cow. I mean, you can read about how big these critters are, you can look at photos, but until you're here standing in front of one, it really doesn't register. And those giraffes that we saw yesterday at the zoo were shorter than this. Significantly shorter than this. This is taller than any giraffe I've seen in real life. And yet it was an animal that flew. How incredible is that? Just astonishing. So yeah. JPG, body proportions remind you of a pelican. Yeah. I mean, these guys, they didn't quite have the same lifestyle as a pelican. Asdarchids like this probably spent most of their time on the ground, it seems. So, right here we've got a representation of that. We've got a Quetzalcoatlus picking up a poor baby Triceratops there. Oh, poor thing. But just like, say, marabou storks, these big kind of ground-dwelling storks from Africa, these guys probably spent the majority of their time on the ground. They were probably kind of generalist predators. And, yeah, they could easily move between different hunting territories by getting up and flying, which is pretty neat. Pretty neat. Limbs on this guy look pretty chunky. Yeah. And somebody was commenting on those backwards pointing fingers. This is correct so far as I know. Yeah. we'll take a look at the arm morphology of these guys. So think about your own arm. Stretch that out like that. You know, you've got your humerus and your radius and your ulna. You've got your elbow in between. This is the elbow right here on this guy. So that is the humerus. So that's the upper arm. The radius and ulna are in here. And so then what is this? There's a technical term for it. I think it's the patagium or something like that. I forget, but I hope I'm recalling this correctly. These are basically super elongate wrist bones right here. So there's the hand, obviously. And then this is basically an extension of the wrist. So like here's the wrist joint, and these are, I think, basically the carpal bones that extend down to the hand. And then the hind limb is pretty much as you'd expect, except I guess they're plantigrade as opposed to digitigrade. Interesting. Very interesting. But what an incredible critter, and so beautifully done too. I mean, the whole thing it's fiberglass, and yet the way that it's painted and the way that it's textured, it really does look like those are pycnofibers right there. These mysterious, you know, insulating filaments that they could be the same thing as feathers, or they could be something distinct. Although there's a general consensus that seems to be forming, those are indeed feathers. Very cool. Yeah, pretty neat. Getting an announcement. It's pretty loud. If you see the bears, you're halfway there. All right. Let's check out that head too. That's a solid, probably 12 feet long. Approaching like 4 meters. Holy cow, just that skull is incredible. What an amazing animal. So Quetzalcoatlus is one of the very last of the pterosaurs. At the very end of the Cretaceous period, this is one of those critters that would have bought the farm at the same time that dinosaurs did. Yeah, they were there for the big mass extinction event at the very end of the Cretaceous period, the asteroid strike. So, yeah. And Zintel says, thanks for the info about those backwards fingers. I know, isn't that cool? It does make me wonder, like, how often pterosaurs would actually use their fingers. Whether this is something that's, I don't know, they could actually manipulate objects with them, or whether it's just basically for traction as they're walking along the ground. I'm not really sure. But yeah, pretty cool. Pretty cool. I mean, just look at that. Extraordinary. What a wonderful use of space, too. I mean, there's a little corner back there that didn't really have anything. They're like, yeah, let's put a Quetzalcoatlus in there, and it'll take up the entire space. That's wonderful. I love that. Yeah. And yeah, they would have seen the asteroid. Exactly, Ellie Bunnies. Exactly. Now, let's go back further in time. Way back to this has got to be early Jurassic, right? Massospondylus. Massospondylus is an early sauropodomorph dinosaur. And so when dinosaurs first arise, they're not very big. You've all seen the Eoraptor skull that I like to show off during some broadcasts. You know, it's about this big. The first dinosaurs that show up in the middle to late Triassic period, they're pretty small. They're about the size of a large dog, or even smaller, potentially. So it takes dinosaurs kind of a while to get truly huge. And one of the first of the larger dinosaurs here is Massospondylus. So this is what we used to call a prosauropod. So these guys eventually evolve into these guys, the big, fully quadrupedal, super massive terrestrial plant-eating dinosaurs like that. But it takes them a while to get there. And Sharkeshe, thank you so much for the gift subs. Really appreciate that. Holy cow. Thank you, thank you. And welcome to Paleontologizing, Shark. It's great to have you here. Yeah. Anyway, so you can see here, these guys are kind of on their way to becoming quadrupedal. Their forelimbs have started to beef up. The humerus, you see, is pretty robust.
Until storms on stage begins down on level 3.
But they're not quite long enough for them to be, like, fully committed to walking on all fours yet. Goodness, those announcements are so loud.
1 minute, come on down. So there.
So dinosaurs start off bipedal, obviously. The very first dinosaurs that we have walked on 2 legs. And for some dinosaurs, especially plant eaters, it behooves them to become 4-legged, quadrupedal over time in order to expand their gut. You know, if these dinosaurs, especially the ones that don't chew their food, they need to have this big, massive gut in order to digest their plant meals. And so that's one of the reasons why we think that they became quadrupedal over time. And this happens in a number of different dinosaur lineages. It happens in sauropodomorphs, these long neck guys. It happens in the horned dinosaurs, like in the Triceratops that we're going to see later. It happens in some of the ornithopods. It happens in the thyreophorans, the armored dinosaurs. Basically, every group of plant-eating dinosaurs. Those announcements. Basically, all of the groups of plant-eating dinosaurs, except therizinosaurs or oviraptorosaurs or ornithomimids, they all become quadrupedal over time, which is pretty neat. And we can kind of see that transition here. Pretty awesome stuff. So yeah. Oh, and thank you, Blue Jeweled. I really appreciate your support. Thank you for that. So yeah. Anyway, let's move on to a non-dinosaur predator right here. So these are critters that died out just before the rise of Massospondylus and the sauropodomorphs like that. This is a big, what we used to call a Rawasuchian. I'm not sure if we still call them that. But this is not a dinosaur. This is a big crocodilian relative that lived around the time of the first dinosaurs. So when the first dinosaurs were evolving, you know, starting to establish themselves in these environments, these guys were the top predators. So not a dinosaur, not quite a crocodile. There we go. Prestosuchus. Very cool. So it's a relative of crocodilians. But what do you notice about the posture on this animal? What's different between this and a modern crocodile? What's going on with its limbs? Does anybody know? You can tell. This is a kind of archosaur, Claire. Yeah. So it's a relative of the first dinosaurs, but it's outside of the dinosaur family tree. It is not a dinosaur itself, if that makes sense. Yeah, and upright limbs. Yeah, not sprawling. Exactly. Encideo, Reno, Lanina, Wanapata, Blejeweled. Exactly. So this is one of these bizarre crocodilians that actually develops an upright posture to it. It's still a little bit different from the posture of dinosaurs. It's not quite on the same level. We can see that here in the ankle joints. So in dinosaurs, they have kind of a fixed ankle like that. That hinge-like ankle that I always talk about. It's the same thing that birds inherited. Yeah, that's what dinosaurs have. This kind of fixed hinge-like ankle. And crocodilians have a different kind of setup. They've got a more rolling ankle joint, like it says here. So their ankles can they've got some like lateral sway to them as well, as I understand it. It's not like the simple hinge that birds and dinosaurs have. So we can see that over here. Yeah. So weirdo astragalus and tarsal bones right there. Really interesting. This is pretty cool. You don't often see these guys as mounted skeletons in museums. So it's nice to see them get some attention here. And this is... I don't know if this is a proper cast. I think much, if not most of this, if not all of it, is a sculpt. A lot of these guys are from like the Chinle Formation. of Arizona. The material tends to be pretty, I don't know, it kind of gets squashed and mangled, and I mean, it's good for being able to determine what the morphology of these animals was, but it's not great for molding and casting. So I think a lot of this is basically a reproduction. It's not a direct mold and cast. It's basically a sculpt based on what we know from the fossils, if that makes sense. Because you'll notice that everything here is really smooth. There is some interesting texture there. There's some gouges there on the femur and on the top of the ischium. I wonder if that's reflected in a real fossil. But yeah, this is for the most part, if not entirely, a sculpt. But it still shows kind of the skeletal anatomy of this animal, and that's pretty cool. Yeah. And were they closely related to synapsids, says Caravan? No. These guys are super far from synapsids. So these guys are basically the same distance from synapsids that dinosaurs are, pretty much, if that makes sense. Just like how Dimetrodon is not a dinosaur, this guy is about as far from Dimetrodon as dinosaurs are, if that makes sense. So yeah, and holy cow, did I get a bunch of new followers? Thank you, Lenina, for letting me know. And everybody who just followed, really appreciate you. It is great to have you here. And welcome to Paleontologizing. Shoot, allow me to introduce myself real quick if anybody is new. My name is Danny Anduza. I'm a dinosaur paleontologist. And normally I stream from my office back in the San Francisco Bay Area. But I don't know, for the past almost 2 weeks now, I think, I've been on a great big road trip, going all across the United States, visiting different field sites, different museums, talking to other paleontologists, and streaming whenever I can. And so today, I'm broadcasting to you from the Minnesota Science Museum in St. Paul, Minnesota. And we're checking out all of the awesome exhibits here, including this enormous flying reptile, Quetzalcoatlus. You'll see another one behind me. It's soaring through the air. And that is what they look like on the ground. These are not dinosaurs, by the way, but they lived at the same time as the dinosaurs, and they went extinct at the same time. Or rather, these guys went completely extinct, and dinosaurs managed to survive in the form of birds. Birds are living dinosaurs. So, yeah, these guys are not birds, and they're not dinosaurs, and they're not still around. It's pretty special to see them here. I've never actually seen in person a big fleshed out Quetzalcoatlus model, so this is pretty special. If you can't tell how excited I am, like I don't know, I'm pretty excited. This is pretty special. But yeah, let's catch up to chat. Yeah, and you know this place, Holy Spoons? Well, aren't you lucky you've been here before? Very cool. But yeah, and Green Herring says, reminds me a bit of a Hoatzin with their wing claws. That's a great reference. Green Herring, yeah. I mean, Hoatzins juveniles do have those wing claws. Those are derived from their dinosaur ancestors. Pterosaurs have those too, though, for walking along the ground. So baby Hoatzins will use those for clambering up trees. These guys are obviously not arboreal. They are taller than a lot of trees, so they wouldn't be very good at climbing. So those claws are there for traction on the ground. And yeah, pretty cool. Pretty cool. This is not the sort of creature you'd want to run into in a dark alley or a light alley, or especially a big open field. Because then they could fly at you too. Like that. Yeah. Holy cow. I could stand here and talk about this all day, but we should move on. See some other critters. So let's go off in this direction. Let's talk about one of everybody's favorite dinosaurs, Stegosaurus. Very, very cool. This specimen looks pretty familiar. That skull, I think that might be the one that, the same one that I have a 3D print of. I think that's the that Wyoming specimen. I forget what it's called, but it's at the, I think, University of Wyoming Geological Museum. Right here. But very cool. And this is actually a good demonstration of, you know, when you're looking at a mounted dinosaur skeleton in a museum, you can see which bones are casts and which ones are sculpts. So this humerus right here, this big shoulder blade, you can see all of the morphology right there. You can see all of these different pits and, like, you know, interesting scraggly bits. That is a replica, a cast of the real fossil. So that is molded and cast from the real thing. But some of these ribs, you can tell, are sculpted. So they are much too smooth in order to be cast from the real thing. But with Stegosaurus, we've got enough specimens of these guys nowadays that we've got a very complete picture of what their skeleton would look like. So those sculpts are probably pretty accurate, you know? They're probably spot on. Pretty neat. And one thing that you'll notice about Stegosaurus and all its relatives to Stegosaurus is that those famous dorsal plates that they have are not actually attached to the skeleton by any kind of bony joint. They're just there kind of free floating in the flesh on its back. And so for that reason, there's been a lot of debate and a lot of going back and correcting old mistakes about how those plates were arranged. So here we've got, I guess this is kind of the modern consensus, is that there is, I mean, depending on how close you put them together, there's either one row or two rows of plates that extend off of the back, but they're staggered in Stegosaurus. They're not paired. This animal doesn't have perfect bilateral symmetry like most vertebrate animals have, which is really unusual. Like, why would they evolve a special arrangement like that with staggered plates? So, like, you know, one on this side, one on that side, one on this side, one on that side, and they are offset from one another. They're not paired, they're staggered. Which is really cool. So they're like scales, says Intaus. They're not like scales. These are actually what we call osteoderms. So the word osteoderm means bone in the skin, and that's basically what this is. Think of it more like the armor plates on a crocodile. We might see a crocodile skeleton later, and I can show you those osteoderms, those armor plates. It's basically what this is. Those plates are made of bone. So they're not scale, they're not skin. That's actually part of the skeleton. They are special bones, but they're not attached to the rest of the skeleton. They're not attached to those vertebrae. So here in this mount, they've got little metal rods connecting them. Yeah. Pretty cool, pretty cool. In fact, let's go look at some of these up close. There we go. And Jody Fish says save on production energy with having the same overall side view. That might well be it, Jody Fish. That might be it. Yeah. And they're like kneecaps, but cooler. There you go, Reno. Yeah. So look at the texture there. Do you see those long kind of furrows going through it? Those like little crevices or ridges? Grooves is probably a better word for them. On the surface of the plates. See those lines going down them like that? Those grooves? So those seem to be what we call like blood vessel grooves or nutrient grooves. It's the same kind of thing that you see like on a claw. There's that nutrient groove that sometimes it's called a blood groove there that supports a sheath of keratin. Or if you look at the, I don't know, if you do a Google image search for like hornbill skull, for a hornbill bird, or cassowary skull, you will see those very similar grooves like we see on these plates on that animal's skull. And it seems to serve the same purpose. It seems to, like, those grooves are there for blood vessels to provide nutrients to a big sheath of keratin over the top. So in life, these plates probably would have been significantly larger than this. You're just looking at the bony core of the plates right here. But with some of these, there would have been keratin that would have extended, maybe even, I don't know, extended the full length by like a third or something like that. And that keratin doubtless would have been pretty brightly colored. These seem to have evolved as a display feature. And so it would make sense that they'd be very, very bright, So yeah. I like to think of stegosaurs as basically being, I don't know. Like when you're driving down the street, somebody's got a really flashy car and it's got hydraulics and it's bouncing all over the place. It's playing really loud music. It's got lights flashing and stuff. I think of stegosaurs as being that of the Jurassic landscape, Just kind of cruising through, showing off, being obnoxious. Yeah, pretty cool. Also, probably not the brightest of dinosaurs either, so I think that analogy works there as well. Very cool. Very cool. Yeah, and being keratin, they could also be sharp on the edges. That could well be true, Jody Fish, yeah. Could be like a bird of paradise, pretty and flamboyant. Yeah, there you go. Zin? Yeah. Blue Jewel says they have such flat heads. Let's look at the head real quick.
So these guys do have notoriously small heads. And we're not really sure why. But they've got a toothless beak at the front. And
this is funny because I have this same specimen 3D printed at home. It's clear I printed mine a little bit too big.
Maybe a few inches too long. But it's the same one. This one's a lot more detailed than mine is. But it's got that same kind of squashed appearance to it where the jaw's kind of shunted to the side like that.
Yeah, pretty small heads. Got a relatively small brain in there. Yeah, these are probably not the brightest of all dinosaurs. But, I don't know, it doesn't matter. These guys were very successful. Stegosaurs have been found on, I think, 6 different continents. North America, or maybe 5. They've been found in North America, Europe, Asia, probably Australia. We seem to have stegosaur tracks from Australia, if not stegosaur body fossils. And there was a new critter just discovered in Africa a few years ago, just published recently, that very well may be a stegosaur as well. Oh, and shoot, we also have Kentrosaurus from Africa. How am I forgetting Kentrosaurus? So we've got them from at least 6 continents, and they almost certainly lived on Antarctica as well. So they were really widespread. They lived all over the place. These are pretty successful animals. So that small head and that small brain seems to have been an evolutionary advantage for them, considering how widespread they became. Kind of took over the world. You don't need to be bright if you're pretty, just like in the modern world. There you go, hair buffing. Yeah, I guess stegosaurs kind of demonstrate that, huh? Yeah. And are there any stego brain case castings? We don't have any here, I don't think, but there are some in existence. You could do a Google image search for Stegosaurus brain cast, or endocast if you want to use the technical term for it. The endocast means like inside cast. It's like a cast of the brain. Yeah. And Science Streams, I'm sure this is not a silly question, Belinda, but let's see. With Stegosaurus, do we have any evidence that the skin and muscles were shaped around the plates? Is there any evidence to the counter that the muscle was one giant hump with internal supports? That is a great question, Science Streams. I really like that a lot. So let's take a look at these plates. For one thing, I mean, we have, if you look at how rugose the bone is at the bottom of the plates, you can see that is kind of where they would attach to the skin. The fact that rugosity is concentrated at the bottom of the plates suggests to us that basically that's the only part that is enclosed by muscle or flesh. That part at the bottom where it's all scraggly like that. See that? If that were everywhere on it, then it'd be like, oh, okay, that's, maybe this whole thing was enclosed by flesh. But no, we don't get that. Also, all those grooves at the top are consistent with a keratin sheath. And as far as I know, keratin is almost always, or maybe always, an exterior sort of thing. You don't have keratin on the interior of your body. That's something that, That's front of the house stuff, you know? It's exposed to the outside world. And yeah. So does that make sense? That's why we think that these are actually external features and not something that would have been enclosed by a fleshy hump or something like that. Does that make sense? Yeah. So yeah, I also want to point out something that I think is really interesting about stegosaurs. This is something that every member of this group has, are the proportions of their limbs. So look at this. They've got these very robust but very short forelimbs. And they've got these, I guess, equally robust, but by contrast they look more gracile, long hind limbs. So this is kind of nuts. We have every reason to believe that these animals were fully quadrupedal. They walked around on all fours pretty much all the time. And so why would they have such a stark difference in the length of their forelimbs and their hind limbs? It might be something to do with their feeding. So maybe they are mostly eating plants that are kind of low down to the ground. Maybe they're mostly like ground feeders, you know, eating ferns, horsetails, cycads, things like that, plants that are growing pretty low. But also it might have something to do with how they defended themselves. Because the primary defense of a stegosaur is not in those plates, it's in the spikes at the end of the tail. Something that's been termed a thagomizer. There's kind of a joke there. There's an old Gary Larson cartoon, you know, The Far Side with Gary Larson, that introduced that term, and then paleontologists actually started using it. But this is the thagomizer right here, that array of deadly tail spikes. So the animal would swing those from side to side to defend itself against predators, and because this is at the back of the animal, it's got to find some way to orient that in order to be able to stick it in a predator's face if it's being harassed. And so having super long hind limbs and relatively short forelimbs might help with that. Maybe that allows these animals to pivot really quickly in order to always have their tail, you know, facing the predator. Because just think about that. If you've got really long hind limbs and short forelimbs, you might be able to just kind of push laterally with your forelimbs and kind of swing yourself around on this central fulcrum here. Does that make sense? So that might be something that's key to the defense of these animals. Pretty neat. You can see right there, he's got a specimen number right on the scapula, which is pretty cool. Pretty neat. P98171C. There. Doing a live stream right now talking about dinosaurs. Yeah. That's a microphone on top. Yeah, that's why it's all fuzzy. Yeah. Do you like dinosaurs? I see you got a dinosaur shirt. Very cool. You got a favorite dinosaur? I am the same way. Yeah, very cool. I'm a paleontologist, by the way, so I work on dinosaurs. Yeah. Thanks. I've got a few, I don't know, I've got a bunch of favorites, I guess. It's hard to pick just one. Yeah, I don't know. I've dug up a lot of Triceratops, so that's a favorite. Working on Spinosaurus, so those are favorites too. You know. Yeah. Oh, thanks. Yeah, sometimes science outreach just means talking to folks when they walk by and look at you curiously, you know? So yeah. Very cool, very cool. And Mothman's cousin says Triceratops is the best. We'll get to Triceratops in just a few minutes. Or at this rate, maybe in like an hour. But yeah, they've got a beautiful Triceratops mount here, so we'll take a look at that. Yeah. Oh, and Triceratops 79 says, how hard were the plates? Asked my 5-year-old son, Isaac. Well, Isaac, that's a wonderful question. Those plates probably would have been very hard. I mean, because if you look at these here, these are replicas of the original fossils. And those are bone. So you can think about how hard your bones are in your body. Like if you, I don't know, you can hit stuff with your elbow and you feel how hard that is. Those are like that too. But not only is it bone, it also would have been covered with keratin. And keratin is the same kind of material like in your fingernails. So imagine if you had like a big bony plate coming out of your back that's bone, but it also has fingernail material over it. That could be pretty hard, right? Yeah. So The plates were pretty hard. A dinosaur like Allosaurus, if it tried really hard, maybe it could still bite through those plates. So it's not like those plates are armor, they're more for show. Those plates would have been really brightly colored, and this animal would have been able to use those plates to say, hey, look at me, or hey, get away, don't mess with me, stuff like that. It's a way to get attention, you know? The stegosaurs were probably very, very good at getting the attention of other dinosaurs. So yeah, does that make sense? Great question, Isaac. Thanks for asking it. Yeah. And yeah, very cool. Oh, and you're talking with Denver? Cool, Hugin. Very cool. Was that on Twitter? Yeah, miss Denver. It's been a long time. Let's check out this right here. Ooh. Who could tell me who this is supposed to be? This is a tricky one. But look at that sickle claw on the hind foot. Look at that long, straightened tail with those long tendons running down it. Actually, I guess those are vertebral processes, actually, rather than ossified tendons in theropods. Anyway, who is this, everybody? Anybody have a guess? It's not Troodon, nor is it Troodon, but it is a relative. It's a member of the same kind of broad group of theropod dinosaurs. It's also a Deinonychosaur, like Troodon, but it's not Troodon. Yeah. Oh, and you're close, Claire Burr. It is not Velociraptor. And Big D's. This is not quite the same one as in Jurassic Park. But this is the critter that gave its name to that family of dinosaurs. That's a big hint right there. Not Dakotaraptor, Hugin. No. Claire Burr, you got it. That is Dromaeosaurus. Yeah. So this is a cast of that specimen, I think, from the Royal Tyrrell Museum. And a lot of this is sculpted, including a lot of that skull. So see if you can point out, if you can notice the parts of the skull that are really detailed as opposed to the parts that are really smooth. You can tell which are cast from the original fossils and which are reconstructed. So the whole top of the skull right there, see how smooth that is? That has all been sculpted. But that material down there, all the scraggly bits, those lower jaws and the maxilla there, those tooth-bearing bones, those are based on the real fossil elements. So Dromaeosaurus, even though it gave its name to this whole group of dinosaurs, the Dromaeosaurs, it's still not super well known. I think this is maybe the best specimen that we have of this animal, found a long time ago. So we don't know exactly what the rest of Dromaeosaurus really looked like, apart from those scraggly bits that you see there. We can look at its relatives, like Velociraptor and Deinonychus, to try and figure that out, but for this animal in particular, and how it's different from Velociraptor or Deinonychus or critters like that, you know, we don't have all the information yet. We need to go out and find more specimens. So I'm pretty sure Dromaeosaurus is from the Red Deer River region of Alberta. Yeah, it might be, shoot. I think it's Campanian in age. I forget which geologic formation it is. Might be the Red Deer River Formation. But yeah. Yeah. And Balint says, is it sculpted because we don't have an intact sample? Exactly, yeah. If you look up the Wikipedia article for Dromaeosaurus, I think it says there right at the beginning. Like, Dromaeosaurus is an important dromaeosaurid dinosaur, but it's still very mysterious. It's poorly known. We don't have a lot of fossil material from it. So yeah. And is that Albertoceratops syndrome? No, that is Centrosaurus, I believe. Yeah, Centrosaurus skull. And see how it's kind of squashed? I mean, look at it. It's kind of like squashed flat like that. That's because it was preserved on its side. And after the animal died and that skull was buried, the rock on top kind of squashed it down. There was a lot of weight there. And over time, like with a lot of things in geology, stuff can become deformed very slowly. Just kind of slowly squashes. And that's how you get something like that. So it's not like this dinosaur was deformed in life or anything. That happened after death and after burial. It got squashed flat like that. Does that make sense? Yeah. And isn't that cool? The presentation on a skull as we hearken. Yeah, nice little pedestal for this critter. Let's see what the placard says about it. Yeah, hunting or scavenging? Yeah, it was Centrosaurus, like I was saying. So yeah. They don't say what formation, but they say 70 million years ago. That would be late Campanian, or early Maastrichtian, maybe 70 million years ago. Yeah. Very cool. Very cool. And so in life, this animal would have had feathers all over its body. It would have looked like some kind of big, scary, toothy eagle with claws on its wings. Not the sort of creature you'd want to encounter if it's hungry. I mean, I'd still want to encounter it, but, you know. Who wouldn't, I guess? Might not survive the encounter, but it'd be cool. It'd be cool. Very cool. And no, Belinda, your questions are great. Please do not apologize for asking good questions. Yeah. Oh, and here, check this out. Oh, I don't agree with this. That's okay. There is, again, moving back to Stegosaurus, going way back in time with Stegosaurus. Can't believe I kept walking past this. This is a lovely display that shows the texture of that plate with all of those grooves. And, yeah, here it says, scientists think that the plates are mostly for controlling its temperature. Hardly anybody thinks that anymore, as I understand it. I've never published on stegosaurs before, but the general consensus among most dinosaur paleontologists nowadays is that those plates were primarily for display. There was an idea originally that the plates acted kind of like the fins on a radiator in order to kind of give off heat or to help the animal warm up. But if you think about it, a radiator has got tubes that run through it, usually with water or some other fluid going through. But those tubes are loops, you know? These grooves right here do not go in a loop. They just go out and then they terminate. So it doesn't seem like this would have been very effective as like a radiator fin. I mean, maybe there was some kind of, maybe it worked like that just a little bit, but it doesn't seem like that's why these plates originally evolved. It seems like they were primarily for display. So yeah, which would make a lot of sense given the texture. Anywho, yeah, they should probably update that placard there. And so Balint says, so if display, was it acting under sexual selection? Great question, Balint. The answer is no. It doesn't seem to be. Man, if you do a YouTube search for Kevin Padian, paleontologist, sexual display, he has a wonderful talk about sexual selection and how it's different from natural selection. It can work in opposition to natural selection. But the way that it's defined and the way that it makes sense is that sexual selection necessitates sexual dimorphism. So the males and females have to have different morphologies in order for that sort of process to actually work. And as far as we can tell, stegosaurs don't have that. The males and the females are identical, as far as we can tell. We don't have any indication, really, that, like, I don't know, there have been a couple papers published, but they haven't really fared very well. Like, that hasn't become widely accepted that there is dimorphism there. So yeah, it seems to be some other kind of display. Maybe it's anti-predator display. Maybe it's ontogenetic display, like in a lot of other dinosaurs, like with the horns and frills of ceratopsians. Yeah, maybe it's some other kind of social display or something that we don't really understand, but it doesn't seem to be for sexual selection. Sexual selection requires that the males and females look different. Think about the feathers on a peacock. The peahen doesn't have those big, ridiculous feathers. With Stegosaurus, it's not like the females don't have those plates. Everybody's got those plates. Males and females, it seems. So, probably not for sexual selection. Yeah. So yeah. And is it also true that we can't tell the sex of dinosaurs? In most cases, yeah. All right, are we back? I'm sorry about that, everybody. That's all right. All right, we're back. I'm sorry about that. I wasn't looking at chat. How long ago did people start saying that we had lost it? Okay, we're back. I'm sorry about that, everybody. That's not a problem with my equipment. That's a problem with the live view interface. It keeps, I don't know. They've got this web portal right here that keeps giving me trouble. It's like automatically disconnecting for some reason, and I don't know why. It's not an equipment failure. It's a web portal problem. I don't know. They need to fix that. So I don't know how much of the last explanation that you caught, but long story short, we really can't tell male and female dinosaurs apart just from their skeletons unless you find eggs in a female dinosaur skeleton, like she's about to lay her eggs. Or unless you cut open the bones and happen to find evidence that she's pregnant. The only female dinosaurs, well, I don't know. The only time we've been able to tell a male or female dinosaur apart is when it's a female dinosaur and there's evidence that she's pregnant. Does that make sense? Yeah. And Big D's, we've only been able to tell male and female dinosaurs apart in I think a total of 4 specimens ever. Out of the thousands upon thousands of dinosaur skeletons ever discovered, only 4 of them we've been able to determine their sex. And they've all been females who are about to lay eggs. So yeah. Like B-Rex, exactly, Mr. Fossil, yeah. So yeah. Anyway, we were talking about that with stegosaurs here. And yeah. Welcome back. See Films, Big D's, Crazy Nut. Shoot, I should do a little intro here. If anybody is just tuning in, I'd like to say welcome to Paleontologizing. Let me introduce myself. My name is Danny Anduza. I'm a dinosaur paleontologist. And on Twitch, I do science outreach. This is my whole gig. I do this full time now. So, when I'm not on Twitch, I'm studying dinosaurs, working and publishing papers, going out and doing field work and stuff like that. But right now I'm on a big road trip going all across the United States, visiting different museums and field sites, talking with other paleontologists. And today I'm at the Minnesota Science Museum, or Science Museum of Minnesota. I always forget. But we are looking at the incredible exhibits here and using them as a springboard for talking about, all kinds of different fossil-related topics. Especially if anybody has any questions, don't be shy, This is how I do science outreach. So, yeah. Later on in the summer, I'm actually going to be live streaming a dinosaur dig, provided our equipment works, cross your fingers, and showing you what it's like to dig up dinosaurs in the field with a crew of paleontologists. So, yeah. And I'm not coming to Drumheller next. No, I'm staying here in the U.S. this summer, Lil Valkyrie. It'd be awesome to come to Drumheller, but not this summer. Yeah. So yeah, and that's exactly right. I can't hear any of the stream sounds or TTS, Reno. That's true. So if you have any questions, or if you just followed and want to tell me that you followed or something so I can thank you, type it into the chat. And to anybody who just followed, thank you for that. I really appreciate it. Welcome to Paleontologizing. All right, let's check out some of these other fossil critters. We've got this beautiful big old Diplodocus here.
And there's a surprisingly out-of-date Triceratops skeleton. We'll talk about why it's out of date in a little bit.
Let's check out some of the maybe more subtle things over here. Let's go take a look at... Here, we'll go off in this direction. Let's see this Champsosaur over here. And... yeah, very cool. So we're going to go forward in time until just after the extinction of the dinosaurs, about 60 million years ago. About 5 or 6 million years after the extinction. We've got critters like these, Champsosaurs. These are such funny guys. I've talked about these guys before on stream. Champa what? Champsosaur. I like this placard here. A champsosaur looks something like a crocodile. And it has a dinosaur-style name, but it wasn't closely related to either of them. It was neither a crocodile nor a dinosaur, but an ancient aquatic reptile. So champsosaurs, these guys are they're so strange and interesting to me. Because it's a critter that I think it's kind of related to lizards. It's not a crocodilian. It's not a dinosaur. I think it might be somewhere near Squamata. I'm not sure. But it's basically like a big, weird, kind of lizardy reptile thing that very badly wants to be a crocodile. They've got these long, narrow jaws like that for snapping up fish. Their teeth are kind of conical and unserrated, like modern fish-eating crocodiles, like gharials. They've got this long, kind of flat body, these short but powerful limbs that we use for swimming. These guys are probably very aquatic, more aquatic than crocodiles and alligators. They probably spent most of their time in the water. And they swam the same way by kind of sculling by side to side with their tails like that. And that is a beautiful example of convergent evolution. Mothman's cousin, absolutely. Yeah. Very cool. So these guys lived alongside the dinosaurs in the late Cretaceous period. I've dug up a zillion vertebrae from champsosaurs in the Hell Creek Formation and the Judith River Formation. Their vertebrae are very distinctive and just everywhere. And then at the end of the Cretaceous period, when the asteroid hits, these guys survive. They make it into the Cenozoic era, the Age of Mammals. And so here we are in the Age of Mammals after the dinosaur extinction, except for birds. And these guys somehow make it through, and then they go extinct shortly thereafter. It's like they managed to make it through one of the worst mass extinctions in Earth history, and then after a while they're like, yeah, we're not doing this anymore, and then they just disappear. It's really strange. I think maybe at the end of the PETM, the Paleocene-Eocene thermal maximum, they die out. But, yeah. There we go. And those look, if they're not the real bones, they're very well painted. Those are at least casts of the real thing. These are not sculpts. The skull is sculpted, you can tell. But that vertebral column and those limbs... Yeah, I bet you those are a cast. The real one, hopefully, is tucked away in a drawer somewhere. It's a beautiful old model. And take a look at the shape of that skull. Got those eyes on top. Very broad back of the skull like that. And big attachment points for the jaw closing muscles and for the neck. Pretty neat. And their nostrils are right there at the front of the snout, which is pretty interesting. Yeah. And they get pretty big. I mean, this is, I think, one of the largest ones. Yeah. Pretty cool. This is bigger than most of the champsosaurs that I've found. The vertebrae are a lot smaller than we see here. Yeah. And how big were its eyes? Crocodile-like, maybe, I think a little bit smaller than a crocodile triceratops, yeah. These guys don't have particularly big orbits, particularly big eye sockets. They probably had pretty small eyes. So here we go. Let's explore the swamp from just after the extinction of the dinosaurs, except for birds. One of those birds is right there. This probably looks pretty familiar to anybody who's spent any time in Florida or Louisiana or Mississippi, areas like that, swamps and bayous. Some lovely turtles, big old amphibian right here. And then there is a mammal. Is that an Oreodont? Who is that?
But it's not in there, yeah. It's just a picture.
Or a Condorarth, maybe? Doesn't look like a horse. Yeah. It takes mammals probably about 10 million years to actually get large after the extinction of the dinosaurs, except for birds. And so most early mammals, or most mammals from the beginning of the Age of Mammals, are pretty small like that.
So yeah, and then, oh, there we go. There are some of our close relatives. These are, is that Purgatorius? Who is that? Our long-lost cousins. Oh, Plesiodapus. There we go. Yeah. Very cool. So this kind of, it almost looks like a cross between a lemur and a squirrel.
These are what some of our early ancestors looked like.
Right up there. Very cool. Great news, great. Oh, there you go, Chuck. There you go. Yeah.
Like an early relative of the primates. So think of that as your great, 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 million times great aunt or uncle.
Or both, here, Chuck. Very cool. Yeah. So, new world, new characters. After the dinosaur extinction, mammals filled some of the empty niches in the ecosystems of the American West and elsewhere around the world. Yeah. Oh, there we go. So it is a condylarth. That's what I was thinking. Not Eohippus. It's not related to horses or anything around today. It says, some condylarth species reached the size of small dogs and were the vegetarians of the day. A few condylarths may have been cousins of today's hoofed mammals, rhinos, horses, antelope, deer, and even whales. So yeah, very cool. Oh, condylarth. Pretty neat. That's one of those groups that
They were pretty successful for a while after the end Cretaceous extinction, and they just disappeared. I don't know what the story is there, whether they were replaced by ancestors of horses or what. But
there's a lovely monitor lizard back there, checking things out. I see a snake in that tree. This is actually a really lovely time for reptiles.
Things like lizards and snakes, because Earth was really warm at the time. After the extinction of the dinosaurs, Earth continued to just get warmer and warmer until the PETM, the Paleocene-Eocene thermal maximum. So it was a great time to be an ectothermic reptile. And that's when you get these gigantic crocodiles like Purasaurus, gigantic constrictor snakes like Titanoboa, you know, a snake that was 30, 40 feet long, something like that. Had vertebrae like larger than your head.
There's some crocodiles just enjoying the Paleocene warmth there. Very cool. And here is a lovely skeleton. One of these guys. Wanaganosuchus brachyvenus.
Skeleton there.
Yeah, just beautiful.
I mean, those look just like modern crocodiles, right? There are some distinct differences in the shape of the skull, but overall,
And I guess with the scoops on the back and everything. But overall, it's very similar to what we've got today.
these are critters that haven't had to change their overall body shape all that much over time. Just 'cause they're very successful at what they do. Yeah. And holy cow, Clockwork Ninja, thank you so much for the gift subs. Really appreciate that. Thank you, thank you. Thank you for your support. It means a lot to me. Thanks for helping fund this trip, you know? And let me bring these awesome museums to everybody watching.
There's Borealisuchus right there. So this is one of those crocodilians that we have before the extinction and after the extinction too.
So I have found plenty of scutes and teeth and other parts from these guys, from the Judith River and the Hell Creek formations.
But it may not seem
and they actually make it past the boundary into the age of mammals.
Supporting science after used to be
Pretty
on
neat.
the truth.
Yeah. This is also one of the crocs that we encounter in the Saurian game. This is the crocodile-y one, is Borealisuchus. Yeah. And thank you, Orchid Twilight. Holy cow. How many bits was that? Orchid Twilight, thank you. I really appreciate that. And welcome back. Hope you're having a good day, Orchid. Thank you for your support. Yeah. And, top crocs. This is cool. And scutes, yeah, here's a crocodile scute right here. They've got this very distinctive texture to them. They've got all these, like, pits and hollows. If you ever find a fragment of one of these in the field, like, you'll know right away what it is. It's, nothing else looks like this. So, pretty cool. Yeah. Very nice. And then right here, oh, this is pretty cool. We've got a field jacket there with a croc skull in it. Lovely. So this is what it looks like in the lab after we open it up. You can see the bits of burlap that are coming out around the side of the jacket. So this is one of those, what we call a field jacket. This is like a protective cocoon that we build around a fossil in the field in order to protect it for its journey back to the laboratory. So we take strips of burlap and then we soak them in plaster of Paris, build a nice cocoon around it, almost like you'd have a cast on a broken arm or a leg. But this is a method that was first devised, I think back in the 1870s by Othniel Charles Marsh's crews. And we've been using the same method ever since, because it works, you know? And here are a lot of the tools of the trade that we use in the field. Brushes, field notebooks, there's a glue bottle right there. Different from, and I would say inferior to the mustard bottle, because you can't regulate the flow with that. It's just an on-off cap. But, yeah. So yeah, not as good as a mustard bottle, but serves the same purpose. We've got pens and hammers and toilet paper. Toilet paper is not, I don't know. I don't think it's super effective for wrapping fossils in, but it's, you know, it serves an obvious function in the field, toilet paper. And there's some burlap and some plaster. Very cool. But yeah, and the placard says much of the equipment used in field work has remained unchanged over the years. This is true. Goods hammers and chisels, plaster and burlap for making field jackets, simple containers for smaller specimens. Compasses, packing equipment, water, and measuring devices are usually needed as well. Paleontologists also use field notebooks for recording finds, mapping their positions, and noting details of the area's geology. All of that is true. Very good. No notes. Pretty neat. Oh, and let's take a look at this display right here. This is cool. This is like an underwater periscope kind of deal. Sit you down there and look at this. We've got a champsosaur about to chomp onto some gar right there. Check that out. Really neat. Very, very cool. Yeah. That is awesome. Got this whole underwater environment here. Gar like that are super common in the Hell Creek Formation and the Judith, and then afterward too. They make it through the extinction. They're still around today. Gar fish like that, G-A-R. And we find their scutes absolutely everywhere in the Hell Creek and in the Judith River Formation and other formations too after the extinction. So yeah. And why is it called plaster of Paris? I think it's made of gypsum, and I think there were some big gypsum mines around Paris back in the early days, and that's why it was named as such. I don't know. That's a guess. I don't actually know that. But Triceratops Isaac asked, how long does it take to dig up a whole fossil? Oh, that always depends. Is it a big critter or a little critter, you know? Yeah, shoot. It can depend a great deal. Certain dinosaurs, if we're talking about dinosaurs in particular, it might take you an afternoon to dig them up if it's a smaller specimen and if it's not very complete. But if it's something very big, like this Diplodocus right here, it can take months, it can take years. Yeah, some of you might remember last week when we were talking with LJ, paleontologist in Idaho. he says, I find sauropods all the time when I'm walking around in Utah and Wyoming, but I don't like digging them up because this is an enormous animal. And I don't know, it can take a whole crew a year or more to dig up something like this. It might take you multiple summers, multiple field seasons. And shoot, it's very rare to also get the whole thing, you know, to get every single bone that's there. And if the thing is kind of diving into a hill, you might have to knock down the entire hill to get to the skeleton. So, yeah, it always depends on... That depends on a lot of different things, how long it takes to dig up a fossil like a dinosaur skeleton. If it's real small, it might take you a few moments. You might just wrap it in tissue paper and put it into a film canister and call it a day. If it's something big like this, it can literally take you years. So, it depends. Yeah. And holy cow, Claire, thank you for letting me know. Orchid Twilight, 30,000 bits. That is incredible. Thank you so much, Orchid. Holy cow. Really, really appreciate that. Thank you kindly. Holy moly. Yeah. That is definitely going to help me pay for gas and everything on this trip, so thank you very much, Orchid. Let's take a look at some more of these critters over here. I'm trying pretty hard to avoid crowds as best I can, because I'm not wearing a mask right now. Let's take a look at these two critters right here. We've got a mammal and a dinosaur. This is a big forest naked bird. Which genus is this? Paraphysornis. Interesting. I'm not familiar with that dinosaur. So after the extinction of the dinosaurs, mammals, of course, come before. They get really big. Here's a big old lictodont, which is related to modern-day armadillos. That's something like what it would appear in life, like this. It's a big old armored herbivorous mammal. This big shell over the top of it with all these osteoderms there. And then right there, we've got this big flightless predatory bird. So after the extinction of the non-bird dinosaurs, birds, it seems, kind of try and reclaim some of their former glory. You could think of it as. You get these enormous predatory flightless birds that evolve during the age of mammals, like this guy right here. And so being a bird, they don't have teeth, obviously. I think the toothless birds are the only ones that survived the end Cretaceous extinction. So this guy doesn't have any teeth per se, but he's got this murderous beak. Take a look at that. Just incredible. Probably would have had a pretty ridiculously strong bite. And walking around on two legs, just like theropod dinosaurs.
Oh, we got plenty of time.
And some of these guys actually re-evolve claws on their wings. I don't know if this is one of those. They've got pretty small wings because obviously they don't fly. And they didn't need to. They had those big, powerful hind limbs. They could run after and catch just about any prey that they were after. And, yeah. Again, not a critter you'd want to encounter in a dark alley. Yeah. And Big D says, what is it about not having teeth that made them successful enough to survive? It's weird as heck. Well, Big D, it might be more luck than anything else. The birds at the end of the Cretaceous period that don't get killed by the asteroid and the ensuing extinction event, those are probably birds that, like, they were kind of generalist feeders. They could eat seeds and stuff like that you could find in the aftermath of, you know, an asteroid impact. So those are the birds that survived. So all of their descendants also didn't have teeth. And some of them later go on to become big carnivores, like that big forest raked bird right there. Does that make sense? It's like the toothless birds were the ones that were lucky enough to survive. And so from then on, the only birds that are around are their descendants who don't have teeth. I hope that makes some kind of sense. Yeah. So yeah. And check out this big old crocodilian. Who is this? Oh, Gavialisuchus. Holy cow, yeah. This massive crocodilian wasn't even full-sized for its species, Gavialisuchus carolinensis. These crocs grew up to 30 feet, much longer than any of their living relatives. They hunted along the South Carolina coast, eating birds, fish, sharks, maybe even young whales. Pretty neat. So kind of like the saltwater crocodile of modern-day Oceania. But these guys lived right here in North America. And check out those teeth. It almost reminds me, they're so thick at the base, it reminds me of the big raptorial teeth in like, shoot, who's the big carnivorous whale? It's named after Herman Melville. Leviathan, I think. Or they almost look like sperm whale teeth, you know? Look at how thick those are. That's nuts. This critter is seriously, you know, it's biting some seriously large things to evolve teeth that are that robust. And a jaw that is that robust too. I mean, look at how well reinforced that is. That's pretty crazy. Gavialisuchus. What a neat critter. Probably a lot more formidable than just about any crocodilian today. I mean, look at that. Look at that. Pretty crazy. Yeah. Awesome. Yeah. South Carolina was the wild east of the Oligocene. Yeah, so there's one of these guys chomping down on an early whale. Very cool. Wow. And then up here, speaking of early whales, we've got this guy. Very cool. They've got similar kind of teeth. I'm kind of surprised at how similar the teeth are between our crocodilian here and between this whale. This is a lovely example of convergent evolution of creatures whose common ancestors do not share those traits, each independently evolved them. So these critters independently evolved the same kind of teeth. These kind of like peg-like, very broad at the base, very powerful, thick teeth. Now check that out. Pretty neat. And speaking of teeth, check out this incredible bird over here. That, if I recall correctly, is Pelagornis. So this is pretty interesting. Take a look. You see those protrusions in its jaw? Those are not actually proper teeth. Not teeth like we have, where they're kind of socketed within the jaw. Those are just projections of the beak. They're what we call pseudo-teeth. And so I talked about how only the toothless birds survived the extinction of the dinosaurs. It seems like certain birds kind of regret that choice after a while. Not choice, but you know, I'm anthropomorphizing them a little bit in order to make this analogy make sense. Certain birds, after the extinction of the dinosaurs, they're like, shoot, well, we don't have teeth anymore. How are we going to catch fish? Some of them actually evolve pseudo-teeth, just like sharp ends that come out of their, like the occlusal surface of their beak. And so those are not true teeth in that. Those are pseudo-teeth. And so they can't be lost or anything throughout life. They can't replace their teeth at all. If they get dulled, then I guess they're just dulled. Pretty neat. So these are some of the largest birds that ever flew, birds like Pelagornis. They're pretty neat. Yeah. And it's Parasaurus from the same time, about the same time, Hugin. Now, Parasaurus I think is from the Eocene, so it's from a little bit earlier. So yeah, maybe you can see right there those pseudo teeth in the jaw. Let me extend the camera. Let's see how close we can get. There we go. Check that out. Pseudo teeth on an Oligocene bird. Pretty neat. Yeah. And TMK says, how old do they get before they die or get eaten? I don't know, TMK. That's a great question. I don't really know a lot about Cenozoic birds like this. Yeah. I guess what I could tell you is that if you want to find that out, there's a few paleontologists you could ask. Bobby Bozenecker would probably be able to tell you. You can find him on Twitter at Coastal Paleo. Or you could look at modern birds like, say, an albatross that also have a similar kind of lifestyle. These guys probably spent most of their time at sea, mostly gliding and soaring in order to get around, diving into the water to catch fish and squid and stuff like that. So you can think about how long it takes an albatross to reach maturity, and how long they live, and then maybe take that and kind of plus it for a bird like Pelagornis. I don't know. It's a great question, and I think histo on birds is pretty difficult too. Actually cutting open their bones to figure out how old they were when they died. I think it's pretty tricky for birds that have such specialized bones, so lightweight for flight, you know. So yeah. Yeah. And Queen Erwinia, I don't get that reference. I don't know anything about Linux. Sorry. But yeah. Anyhow, an orchid twilight. Holy moly. Wait. How many was orchid twilight? That is extraordinary. Thank you so much, Orchid. I don't even know what to say. Holy cow. 1,000, 2,000, 3,000, 4,000, 5,000, 6,000, 10,000. 10,000 plus more. How many bits was that, everybody? That's extraordinary. Thank you so much. Holy cow. I don't even know what to say. That's brilliant. Crazy. Thank you so much, Orchid, for your ongoing support. You are a big part of the reason why I can do this right now. So thank you. Yeah. It was all the bits, Danny, says Reno. I guess so. 1,737% hype train. Will I sing in the museum? No, SV Harkin. I didn't bring my ukulele. It's back in the car. But yeah. Let's take a look at this painting right behind us. Is this an original Charles Knight? Or is this a reproduction right here? This lovely reconstruction of Stegosaurus. Classic. This has been reproduced a million zillion times, especially for anybody maybe a little bit older in the audience right now. Over the course of your life, you've probably seen dozens of Stegosaurus pictures that were inspired by this painting right here from Charles R. Knight in 1930. And that's really cool that it's here on display. And no, that's not an original. That's got to be... Oh, is it an original? Huh. Very cool. Yeah, pretty sure that's on a stamp. I'm sure it's on dozens of different stamps. Yeah. Display here. It says Charles Knight painted dinosaurs in a new light. We talk about Charles Knight all the time on this channel. In fact, when we were at Dinosaur Park in Rapid City, I was talking about Charles Knight and how his work really shaped public perception of dinosaurs and helped shape scientific perception of dinosaurs too, to a certain extent. So this is Charles Knight helped change the way people looked at dinosaurs in the early 1900s. Instead of depicting them as lumpy, lizard-like specimens, Knight breathed life into his extinct subjects. He painted them in action in the vibrant colors they might have had in life. So there he is, working on a Stegosaurus model, probably to be used as a maquette in order to light and paint in proper perspective. Charles Knight was an incredible artist, incredibly influential. And a lot of people don't know this about him, but the man was nearly blind. he was extremely nearsighted to the point where he could. Today, he would be considered legally blind, I think. And yet, it's almost as if he could see directly into the past. Yeah, pretty cool. We'll talk about him another time. But there's so much to talk about with Charles R. Knight. Got to figure out when his birthday is, and we'll do a special stream on that day about the work of Charles R. Knight and his legacy. Yeah, let's take a look at some of these critters. This is pretty funny. Bamburaptor. When we were talking about Bamburaptor, we did a dinosaur deep dive on this critter a while ago. This is a juvenile dromaeosaur. Probably a juvenile Sauronitholestes. It's from the same time and place, basically. So yeah. And this is a cast of the skeleton right here. I don't remember where the original is. It might be at Museum of the Rockies, actually. But there we go. Who could tell me what that is right there? That kind of U-shape or shallow V-shaped bone. That is the furcula, the wishbone, right there in this critter. Look at how slender those bones are and how big that eye socket is. It's clearly a juvenile animal. Yeah. Pretty neat. And there's a slightly goofy reconstruction. Now we realize this animal would have had feathers all over its body. Would have looked far more bird-like than that. You know, big feathers coming off of the tail. Big feathers, like flight feathers, coming off of the arms. So this could really use an update here. But let's just admire this skeleton for a minute. What a beautiful little juvenile dromaeosaur. Look at how thin and delicate those bones are, how graceful they are. That is exquisite. Just beautiful. Holy cow. Yeah. Unfurcula was also stated in bold on the plaque. Okay, Zentaus. But yeah. And Anonymous Cheer, thank you for those bits too. Really appreciate that. That's lovely. Yeah. They need to unpluck that plucked chicken. You were right, Trek Nerd. Yeah. Yeah, this critter should have feathers all over its body. It should look like some sort of big, weird, ground-running eagle or something like that. Or not big. I guess it's about the same size as a big eagle. But yeah. I don't know. Put more feathers on your Dromaeosaurus museum. This museum's too beautiful to have such an outdated display like that. I don't know. It doesn't seem to be up to the standards of the Science Museum of Minnesota. Let's go make a beeline over there to that big old fish. And we will talk about Xiphactinus, Cretaceous bulldog fish, as it's sometimes called. Yeah. And yeah, they could do an AR update. That'd be pretty cool, Clockwork Ninja. Yeah. Alright. This critter right here is a fish that lived at the same time as the dinosaurs in the western interior seaway. So let's set the stage. This is what North America looked like in the late Cretaceous period. So Florida is still underwater, as is most of California. And then the interior of the continent, or modern-day Nebraska and Kansas and the Dakotas and eastern Wyoming, all this area through here was covered by a shallow, warm inland sea that we call the WIST, the Western Interior Seaway. And inhabiting this were all kinds of weird and wonderful critters, most of them carnivorous, as things are in the ocean. Things like mosasaurs, which we will see out here in just a moment. Or a few moments. We'll see when we see our mosasaur. But yeah, giant seagoing lizards like that. And even the fishes were big and ridiculous and predatory and scary. Chief among them, Xiphactinus. So it kind of bears a superficial resemblance to a modern tarpon. If you've ever heard of that fish, Tarpon, tarpon. But it's not really related to them, as I understand it. Check this fish out. Just absolutely incredible. We did a non-dinosaur deep dive on it a while ago. And Here it is. This is a lovely cast of that critter. And that's a solid, I don't know, it's probably 15 feet long, so approaching 5 meters.
In like 50 million years.
Pretty extraordinary. Let's check out those teeth real quick. Take a look at those. Yeah. Very cool. Big ol' eye, too. This is basically a, I don't know, a teleost fish that's like as big as a white shark. Enormous. And this is not the top predator in its ecosystem. Not even close. Pretty cool. Pretty cool. All right. Speaking of fishes, let's take a look at some other beautifully preserved ones. I bet you these are from the Green River in America. Let's see. Yeah, there we go. Oftentimes when you see really beautiful, well-preserved fishes in a museum, they're from the Green River Formation. And holy cow, this is a bowfin here? Huh. Look at that. I think this is bigger than any bowfin get today. Just extraordinary. So this same kind of fish still exists today. It's the same genus even, genus Amia, A-M-I-A. They go back to the age of dinosaurs too. So this is a fish from after the extinction of the dinosaurs, from the Eocene and the age of mammals. So about 50 million years old, give or take. Yeah. And then we've got a stingray right here. And look at how beautifully preserved that is. That is exquisite. Just extraordinary. And so that is the original fossil here too. Very, very cool. And here's some more. We've got some Lepisosteus. This is a genus of fish that's also still around today. These are gar. So have you ever heard of alligator gar? This is a close relative. Actually, no, Lepisosteus, I don't know if that genus is still around. Somebody can look it up. Is Lepisosteus extant? Yeah, 50 million years ago. From the Eocene. And you can see those ganoid scales in there. They basically have like a bony suit of armor all around their body. Bony scales. Made of a material that we call ganoid. Alright, are we back? Sorry everybody, it's the web portal was acting up again. But we're back on now. Excellent. Hopefully that's that was a new record for getting back online. Thank you everybody who stuck around too, who didn't just immediately leave when things went dead. Yeah, I don't know. I need to talk to LiveView about the web portal thing because it just keeps dying on me. Anyway, I was talking about these beautiful gar right here, and it is just so nice to have. It is so nice to have them intact like this, to not just have thousands of scales scattered everywhere. If you detected a tiny bit of, I don't know, wistful trauma in my voice right there, it's because of just the thousands of gar scales that I've had to pick through in the laboratory and dig out in the field. So it's cool to actually see them intact. I've never seen one intact in the field. And these are probably Nicia. Yeah, they are. Nicia. These are the most common fish, as far as I know, in the Green River Formation. There are thousands upon thousands of them that have been dug out of these strata. And chances are, if you ever go to a rock shop and you see a fossil fish for sale in that rock shop, it will be Nischia. These guys are super, super common, and they occur on a lot of private land in the Green River area of Wyoming, and so you frequently see them for sale too. Pretty neat. So I think these might be related to modern perch. I don't really remember. But pretty cool. What a remarkable slab, just all of these beautiful fishes all together like that. Yeah. And Big D says, how did that many fish die at once and get buried fast enough to have this type of fossilization happen? I don't know. Maybe there was a red tide event or something like that just kind of killed everything in the water nearby. And then I don't know enough about the depositional setting for the Green River Formation. Somebody can look that up. I wouldn't be shocked if it were... I mean, it'd make sense if it were volcanic, but I don't know if there's any evidence for that. Yeah. There's even a chance it could just be slow and attritional, it's just one fish after another dying over days and days and days, and then they slowly accumulate. But I don't know, those ones all seem to be kind of in the same place. There was probably some sort of mass casualty event that occurred. Yeah. And it could be oxygen depletion in the water, sure. Triceratops, I don't know. Yeah. Let's take a look at some of these guys over here. Different mammal skeletons. Yeah, beware a saber-toothed ambush. Very cool. And we saw this guy earlier, Hoplophonius. That is a nimravid. We saw those at the Geology Museum in Rapid City, at the School of Mines. So that is not a cat. Notice how the forelimbs and the hind limbs both look different, and the skull looks a little bit different too. So that is another kind of saber-toothed mammal, not a cat. So that's, again, a lovely example of convergent evolution. Got the feeling we're going to see a lot of examples of convergent evolution over the course of this road trip. There's one of them right there. A non-cat, saber-toothed non-cat. There's an oreodont right there, which are these super common mammals. I think they're a type of creodont, oreodont. I don't know. I don't know my Cenozoic mammals well enough, especially the early weird ones like that. Yeah. What's in the middle of an oreodont? Meat, says the sign. Oreodonts, like this Maricoidodon, were the most common plant eaters of their time. Distantly related to pigs and deer, they lived together in herds for safety. But they still probably made a convenient meal for carnivores like Hoplophonius and Hyaenodon. There you go. So these, I guess, are even-toed ungulates. These would be artiodactyls, related to pigs and deer. So what you might call cloven-hoofed mammals, to use an antiquated term. Or artiodactyls, if you're a scientist, you know? But I love that joke. What's in the middle of an oreodont? Meat. Somebody was having fun with that sign. Yeah. Yeah. Oh, and thank you, Jody Fish. It's Varv deposits. Oh, okay, in the Green River. That makes sense. So those fishes that we were talking about earlier. Varv formation. Interesting. Yeah. And Clockwork Ninja, I have never really worked on Cenozoic mammals. No, I've never dug up Cenozoic mammals in the field. Yeah, never. I've dug up some Cenozoic fishes in Wyoming and Nevada, but I've never dug up any Cenozoic mammals. Not yet, at least. Yeah. So yeah, Leptomeryx, very cool. Little hoofy guy. Original and cast composite. Very cool. So there's real fossil bone there. You can tell that these are mounts that were produced a long time ago. Yeah, these must be like classic mounts that they used to have here in the museum, and they were just too beautiful to keep back in the collection space. So here they are on public display. Very cool. And there's Hyaenodon. Hyaenodon's jaws were no laughing matter, according to the sign. And it says Hyaenodon was only a distant relative of modern-day hyenas, but the two carnivores share an impressive feature, crushing jaws and teeth. Hyaenodon probably hunted and scavenged. Their powerful jaws could have carved off hunks of fresh meat or cracked through solid bone, just like a modern hyena. Pretty neat. I think these guys show up. Some of you are probably familiar with them from the Walking with Prehistoric Beasts series. I think Hyaenodon makes a few appearances there. But, yeah. Very cool. And then we've got an ancient camel. So we were talking about this at the museum in South Dakota as well. Camels didn't start off big. It started off pretty small. About the size of what kind of dog would that be? I don't know, Basenji? Something like that. I say that like people immediately know what a Basenji is. You know, like a medium-sized dog. Yeah, pretty cool. Check that out. Now, compare that to the camels that we were looking at yesterday. It is significantly smaller. Yeah, because again, most critters don't start off big when they first evolve. Yeah. And just like we were talking about yesterday, yeah, camels first evolved in North America, and many species were once common here. Varieties like this little Poebrotherium, wandered the continent's grasslands for millions of years. But then, when the last ice age ended about 13,000 years ago, America's camels went extinct. They very well may have been hunted to extinction, along with the rest of the North American megafauna. But, yeah. And, okay, thank you, Claire. Some people do know what a Basenji is, yeah. Barkless dog and presumably barkless camel? Yeah. Very cool. Little mini camel. One of the earliest of the camels, I'm guessing. Pretty cool.
Oh my gosh.
Pretty cool.
We have to see this. We have to see this.
All right. Oh, and everybody knows this critter, Otodus megalodon.
We have to see
Megalodon
this.
shark. Big old teeth. I've got a cast of a megalodon tooth in my office, and it's about that size right there. It's pretty big. It's almost as big as my hand. So they lived from about 10 million years ago until about 2 million years ago, when they're prey species. They fed on all these ancient kind of smaller whales, and when the prey went extinct, they went extinct too. Pretty neat. And these are originals here. Very cool. That's neat. And then the Megalodon casting project. Scientists in the Paleo Lab are making near-perfect copies or casts of the fossil shark teeth in the case to your left. These huge teeth come from Otodus megalodon, the largest predatory shark of all time. We want to preserve these details in the casts. To match the weight of the real fossils, for example, we're mixing steel powder and pellets into the casts. Interesting. With careful work, each copy will look and feel just like the original. Pretty neat. But why are they... I wonder why that is. They're trying to make them... I wonder if they're going to use them for some sort of kinetic study or something. So they need them to be the same mass. Very cool. All right, let's go ahead and continue on over here. And yeah, let's take a look at this critter right here real quick. Is this a Uintathere or something?
No, it's a rhino.
Somebody clearly had a lot of fun writing up these placards. Oh, give me a home where a rhinoceros roam. North America became drier 20 million years ago. Forests shrank and grassy plains took their place. It was the perfect environment for larger herbivores like this rhinoceros.
Whole herds of rhinos grazed the plains, sometimes fossilizing in spectacular groups. And here's a reconstruction of what the animal may have looked like in life. Compare this to the rhinoceros that we saw at the zoo yesterday. This one's significantly smaller. But it goes to show that rhinos used to be a lot more diverse than they are today. Throughout Earth history, there have been many sizes and shapes of rhinoceros. One's smaller than this, and one's much larger than this. In fact, the largest land mammal that ever lived was actually a rhinoceros. What we call Indricotheres or Paraceratheres. Things like Indricotherium, Paraceratherium, Belucotherium. I don't know what the proper name is nowadays for those critters, but it's basically like a giant rhinoceros that's evolving to look like a giraffe. Big, long arms on it, kind of like an upward tilt to its body. Look them up, they're really cool. Indricotherium and Paraceratherium. So, I don't know, rhinos used to have so many different kinds. And nowadays we've got, 5 extant species? And they need our help, so, yeah. Anyway, rhinos, really cool critters. Really cool. So this one right here is called Minoceros. There we go. And Paraceratherium, I don't think it was a forest dweller, no. Paraceratherium was probably too big to live in any forest, I'd imagine. Sophie probably lived out on the plains. So yeah. And thanks for posting that link, Claire. Just trying to give you some idea of the diversity of rhinos over the years. It's funny, all of these mammal skeletal mounts, they're clearly from another time. And it's cool that they're still up on display here. The dinosaurs really take center stage, but it's cool to see the mammals as well, you know? I'm not gonna deny that. And why isn't the horn part of the fossil? It says Triceratops. These guys probably didn't have a horn. Or if they did, it probably wasn't... Oh no, they did, according to this illustration. That's the thing about rhino horns, Triceratops, is that rhinoceros horns don't have a bony core to them. It's entirely, for the most part, I can't say entirely, because I don't want to be wrong if that's a little bit wrong. But anyway, rhinoceros horns are soft tissue, basically. They're made of keratin, the same kind of material that your fingernails are made out of. So unlike dinosaurs, whose horn cores almost invariably are bone, rhinoceros are not like that. Yeah, does that make sense? It's the same for modern rhinos. So if you look at a rhinoceros skull, if it doesn't have the keratin part, you're not going to see a horn on it. Does that make sense? Now compare that to our Triceratops here, who's looking more than a little bit goofy. This must be a very old mount for this Triceratops, because there's a lot wrong with it. But it's still instructive to see. Its tail is like practically dragging on the ground right there. In fact, look, they kind of carved out this so that the tail wouldn't be contacting the ground. And the front limbs, look how far they're sprawling like that, and how close the chest is to the ground. Basically, it's sprawled out like a lizard or something. We know that that's not how these animals actually look. It should be more upright, holding its head higher up, a more proud stance. You can tell this is Triceratops prorsus right here, from the upper Hell Creek Formation. Because it's got that big, pronounced nasal horn right there. With Triceratops from lower down in the formation, they've got a smaller nasal horn. And, this is definitely Triceratops prorsus. See that kind of smooth, almost like a ski slope. Like that. Pretty cool. And it's got those really broad bases to the brow horns there, characteristic of T. prorsus. Pretty neat. And why don't they change it, says Snowpied Pupie. I guess it would be too difficult. I mean, with this is a cast, obviously, and so this is like, a more or less exact copy of the original. And those metal rods are going straight through the bones right there. And so just structurally, I'm not sure if they're able to move it at all, like without just everything breaking. So I guess they've got to keep this really old pose for it.
But this is how we thought dinosaurs looked in like the 1950s, basically. Yeah, nowadays we realize there should be a more upright, kind of graceful posture.
Yeah.
Pretty cool. Pretty cool. I could stand here and talk about this all day. And Kia Britt says, Danny, make sure you go race the Tyrannosaurus in the sports section. Ooh. I don't know if I can run very fast with this whole live stream rig setup, but maybe I'll give it a shot. Yeah. How fast did they say Tyrannosaurus was in that thing? Because it's still a matter of debate among professional paleontologists. We still don't really know. If somebody asks us, how fast was T-Rex? An adult T-Rex still, I don't know, very much disputed how fast they could run. I'm sure a young T-Rex could definitely outrun me, though, and I'm pretty fast. So, yeah. Anyway, beautiful critter. Yeah. And do the gastralia connect with the ribs and Triceratops? I don't think so, Jody Fish. I don't think that's correct right there.
Maybe that's just to hold the ribs in place.
Maybe it was simpler to do that, but I don't think these guys have got like a sternal plate with gastralia coming off of them. I don't think ornithischian dinosaurs had gastralia. I think that's just a Saurischian thing, maybe even just a theropod thing. So I'm not sure what's supposed to be going on with that kind of basket work of
Sternal ribs like that.
I don't think that's how these guys actually work. Huh. Check out that humerus too. Look at how robust this is. That big upper arm bone there. Just crazy. And it's got this enormous crest on it for muscular attachment. Just extraordinary. I mean, compare that to your own humerus. That's pretty nuts. Pretty nuts. They have such robust bones. It's incredible. Yeah. And Triceratops 7. Oh, wait. Who was saying that? Staccato or vibrato. Not as fast as a 93 Wrangler, according to Spielberg. I don't know. A 93 Wranglers would be faster than a modern one because it's less likely to break down. It's a good thing they weren't driving a 2022 Jeep in that movie. Anyway, yeah.
Very cool. Look at those the ischium bones hanging down like that, back of the pelvis. It's so cool. Triceratops ischia, ceratopsian ischia are so distinctive. There's a beautiful downward curve to them. Nice and graceful. Pretty cool. Pretty cool.
Yeah, very neat. And Triceratops bones are not hollow. Yeah, that's a good point. Especially with ornithischian dinosaurs, it doesn't seem like they had the same kind of adaptations that theropods did, or sauropods, to lighten the bones. Like out of all the dinosaurs, ornithischians, the bird-hipped dinosaurs, oddly enough, are the ones with kind of the densest bone, it seems. They don't have the same kind of overall hollowness that other dinosaurs have, like sauropods or theropods. We've got a lovely pterosaur up there. What is that? Is that Pteranodon or Nyctosaurus or somebody else? Not sure who that is. We've got a lovely flying pterosaur right there. Not a dinosaur, I hasten to add. These guys were contemporary with the dinosaurs. They lived at the same time. They flew over the heads of dinosaurs, but they were not dinosaurs themselves. The pterosaurs, or pterodactyls, as many members of the public call them. Yeah. Pretty cool. Yeah.
Now let's check out. Holy cow!
An Apatosaurus femur. This is significantly larger than my own femur. Check that out. And this is the real bone right here. So you can see where it's been filled in with, that looks like plaster there. It doesn't look like water putty. In the old days, they'd use plaster for this. And pretty cool. I'm sure the collections manager is pretty happy that this doesn't have to stay back in collections. They could just shunt it off into the display area and not have it take up a bunch of space back in collections. But this is the femur of Apatosaurus. Yeah. This is the largest bone in almost any dinosaur's body is the femur. It's also the largest bone in your body and in mine. Pretty cool, pretty cool. So this, so what we're looking at here is a left femur. This bone right here. And you can tell it's the left one because those processes are extending backwards right there. That'd be where the knee is. And that is the articular process. So that articulates with the acetabulum. And so that fits into the hip socket right there. And so this would be the way that the femur was oriented in life, too. Dinosaurs had their femurs directly underneath their bodies. Unlike crocodiles, unlike lizards who have kind of a sprawling posture, dinosaurs walked upright. And their femurs tell that story. We've got that process going into the hip socket at like a 90-degree angle. So, like that. Pretty cool. Pretty cool. And what do you have to study to become a paleontologist? Vinegar bowl. What? Oh, Claire, I see what you did. No, that's what acetabulum means. The hip socket. The technical term for that is acetabulum, and that literally means vinegar bowl. Yeah. But what do you have to study to become a paleontologist? Says Snowy. It depends what kind of paleontologist you want to be. I don't know. For a broad answer for this, I would say if you want to become a paleontologist, you want to take as many geology and as many biology classes as you can. Because paleontology, in a way, is kind of a weird mix of biology and geology. Personally, I'm much more on the biological side of paleontology. I'm not a very good geologist. And I mostly work on like dinosaur functional morphology and stuff like that. But yeah, studying modern animals is a great way to learn some things about extinct animals too, kind of by analogy. But also, there are paleontologists who have their background in chemistry, or in geology, like I said, or in biomechanics, or in computer modeling. There are almost as many ways to be a paleontologist as there are different paleontologists. There are so many different ways that you can study extinct life. You could do it through chemical means. You could do it through computer modeling. You could do it through actually going out and digging up the fossils in the field. You could do it through I don't know, there's a bunch of other ways of doing that. You can also study taphonomy. There's some really important work going on in how fossils actually form, like how creatures after they die get buried and how their bones get scattered and that kind of thing. If you can figure out those processes, then you can actually learn a lot about ancient environments and about you can kind of separate the signal from the noise when you're looking at an animal's skeleton buried in the ground. You can figure out how much of that is like the way the bones are arranged, how much of that is actually because of the structure of its body, and how much of it is due to decomposition and stuff like that. So I don't know, paleontology, it's honestly one of the broadest sciences that there is, and there's so many different ways that you can approach it. So it's a great field for so many different kinds of people. No matter what you're interested in, chances are you could use your area of expertise for learning about ancient creatures, which I think is really cool, really exciting. By the way, if anybody is just joining us, allow me to introduce myself real quick. My name is Danny Anduza. I'm a dinosaur paleontologist, and I'm here at the Science Museum of Minnesota right now, looking at their natural history displays, their fossil displays, and talking dinosaurs. Normally on this channel, I do lots of Q&A, talk to people about, answer their questions, talk about the latest fossil news, go over new publications, all kinds of stuff like that. Right now I'm on a big road trip going all across the U.S., stopping in different states, looking at different museums and field sites, and talking to other paleontologists. And right now we're exploring this lovely museum in St. Paul, Minnesota. And it has been a joy so far. So I'm so glad you're with us. Stick around. If you've got questions, don't be shy. I'm here to answer your questions. That's my whole point. So, any study of fossilized weather? Yeah, paleoclimatology, Death of Barney. That's definitely a thing as well. If you really want to understand an ancient ecosystem, you've got to understand its climate, All right, let's go over here. We'll go past our Diplodocus. We'll check him out in a little bit. Let's go over here and check out Camptosaurus. Holy cow, this is a big old Camptosaurus. Speaking of big bird-hipped dinosaurs like we were. And Allosaurus right here. Doing some sort of hand signal. I don't know what's up with that. But yeah. Very cool. And we have a fallen Camptosaurus right there too. Camptosaurus is such an interesting, I think, underappreciated dinosaur. So this is an iguanodon. So related to iguanodon, but earlier. It's from the late Jurassic period of North America. And they are so cool. It's neat seeing one that's this large, and it looks to me like much of this skeleton, if it's not real bone, then it's cast at the real thing. Some of that really does look like this is real bone. That's not a cast. Holy cow. This must be a really old specimen where they still put metal armatures through the bones. But it's in a nice modern pose. I think that's really cool. Yeah, this one here clearly is a cast, mostly sculpt. Cool stuff. Yeah. And you thought they were smaller Sismorphosaurus? No, some of them get really large. It's funny, if you could almost slap plates on this thing and call it a Stegosaurus. Although its tail is a lot longer. They probably had a similar kind of, I don't know, probably eating similar things to Stegosaurus, I would imagine. But, this is an early relative of later dinosaurs like Iguanodon. And these guys would become super, super successful in the Cretaceous period afterward. The descendants of these guys, especially the duck-billed dinosaurs, really take over the world afterward. But they really started to, kind of come into their own during the late Jurassic, it seems. With dinosaurs like Camptosaurus. Pretty neat. So the name Camptosaurus means bent lizard, and I'll show you why. Does anybody have any guesses why it's called bent lizard? We'll see if anybody can guess. Oh, and thank you, Hegpets, for clipping that with the pseudo teeth there. But anybody have any guesses why Camptosaurus is called the bent lizard? The neck, hunchback? These are good guesses. It's really kind of a disappointing answer. But I'll show you. It's something subtle about the animal skeleton. It's right there, the femur. There's like a slight bend to it. There you go. That's where the name Camptosaurus comes from. As I recall, anyway. Yeah. I don't know. Sometimes, because names in science get conserved because they kind of can't change unless there's a really, really good reason. Sometimes you get stuck with very underwhelming names for very cool critters. So Camptosaurus is one of those. Yeah. More of a bow than a bend, says Gary Oster. I know, right? Yeah. Now, there's probably some really interesting stuff going on with Camptosaurus in the Morrison Formation. Stuff going on with its ontogeny, stuff going on with its evolution over time, and not too many people are studying this animal right now.
To me, it looks like.
I was talking about this with LJ, and
Definitely a herbivore.
yeah, I don't know. He's going to be digging up some Camptosaurus, hopefully, at some point in the next few years, and helping unravel some of the mysteries about this animal. Because it is kind of understudied. It's an important critter, but yeah, not enough work is being done on it. And look at those hands. I've got a cast of a Camptosaurus hand at home, and it's about half the size of that. Maybe even 1/3 the size. Really cool.
T-Rex is way bigger than the Allosaurus, but the Allosaurus.
And check out the just the difference in robusticity between the forelimbs and the hind limbs. And take a look at that. It's still pretty robust, the humerus and the radius and ulna, but then compare that to the hind limbs. Let's just look at that, yeah. So these guys may have been facultatively bipedal. Maybe they're walking around on their hind limbs most of the time. But yeah, they could kind of switch between quadrupedal and bipedal, depending on how they're feeling with it. So yeah, pretty neat. Very cool. Now, switching from dinosaurs briefly right here, let's take a look at this. Big old cephalopod right here. This ancient squid relative was a helmeted hunter. This is Endoceros, I guess. And this is from Minnesota, is that right? This is the original right here. Big old kind of cone shell from a cephalopod. What a cool critter. That is pretty awesome. So this is an ancient relative of squid and octopus and ammonoids, like your famous ammonites and stuff like that. But yeah, from right here in Minnesota. That's pretty neat. Pretty neat. Some local pride on display. And this is the original, of course, not a cast, not a replica. That is the real fossil right there.
Good afternoon, science fan. Starting in just 7 minutes.
Yeah.
On Storms on Stage.
Man, that's a loud announcement. We'll just wait this out for a second.
Vortex on stage in front of your very eyes. Come on back to level 3. On your way back, you'll see the bear, and you're halfway there. The storm show starts in just 7 minutes.
Very cool. What a neat dynamic display here. Are those some cycads right there in the middle? I didn't even spot them. Let's go take a look at those real quick. Then we'll talk about Allosaurus. And thank you, Kia Britt, for that gift to Kanar. I really appreciate that, Kia Britt. Thank you for your support. That is lovely. Yeah. And Kanar wanted to know, which dinosaur do you think deserves far more credit than it gets? Oh, shoot. Camptosaurus is one. I don't know. Maybe Falcarius? That early therizinosaur from North America. Doesn't get as much attention as it deserves. Yeah, I don't know. Others like that. I also think a lot of the small, beaky, plant-eating dinosaurs, what we used to call hypsilophodonts, are far more interesting than they get credit for, too. Yeah. Here, just a second, when those folks move, we'll take a look at those right there. Those look like cycad cones. Not cones, but cycad trunks. Fossilized in the middle there, and I bet you those are real. We saw some of those at the Geology Museum in Rapid City, and now we're going to see some more right now. I think that's what they are. Let's go check. But yeah. Yeah.
Science Fair started in just 5 minutes on level 3, Storms on Stage. This free show is about 20 minutes long, and it's free for all ages. Please come on down to level 3. If you see the letters, you're almost there.
We'll take a look at this in a second, too. We've got a display on copper lights here. But first, let's check out this. It's got to be a cycad, right? Yeah, Cycadoidea. So it's from the cycad order. From South Dakota. Very cool. Check those out. These big old cones.
from this kind of plant right here. My favorite kind of extant plant. They're still around today. Well, they're much more rare than they used to be. They used to be everywhere, all across the globe. One of the dominant kinds of plants. Just ubiquitous. And
They are also, I think this is true. Somebody can look it up, but I'm pretty sure that they were the namesake of the only U.S. national monument that was done away with. Cycad National Monument used to be, I don't know, a really cool place with all of these beautiful cycad trunks, all preserved, ones like this. And that was really the selling point of the whole national monument. That's why it was preserved in the first place. And unfortunately, people decided to take little chunks of them as souvenirs, and some people even hauled away whole ones until there was nothing left. So now there is no more. Now there is no more Cycad National Monument because of that. Somebody look that up real quick and see if I'm right.
Don't miss your chance to see this show starting in just now 3 minutes. Did I mention it's free? You already paid for it. You don't want it to go to waste. This is your final chance of the day, so come on down. You see the
Is it our final announcement of the day too? Man, that's loud.
yeah. Anyway, cycads. I bet you these are from there. Was it in South Dakota? Was Cycad National Monument in South Dakota? Because I bet you these are from there.
So yeah, if you're ever visiting a national park, please listen to the park rangers. Do what they say. Don't, take only photographs, leave only footprints. Because at Cycad National Monument, people did not follow those rules, and now there is no more Cycad National Monument. So yeah. There we go. Yeah. Lost but not for interesting tumor boy. I should check that out. Yeah. All right. And happier news. We've got an Allosaurus right here, and he is waving hello to everybody on chat. So, would you like to wave back to him? This is a really old pose for our Allosaurus here. Not only is he doing something funky with his arms, but look at how wiggly waggly his tail is. It also seems way too long. I think they put in too many vertebrae. Way too many vertebrae.
only 2 more minutes.
Are we going to get an announcement every minute?
Come on down and get your seats. Doors will be closing soon for this free show where you get to see lightning and a fire vortex on stage.
Yeah. The tail is way too long, and see how it's dragging on the ground, and it's also all wiggly waggly.
Dinosaur tails, for the most part, are not like this. They were held out behind them for balance. They would have been much more stiff than this.
Like you see right there, with our Allosaurus. And that lovely mural right there. Those tails are for balance. They're not wiggly waggly, ground draggy implements like you see here. They are wiggly waggly on our Diplodocus, which we'll talk about in a minute, but they also didn't drag on the ground there either.
Just 1 more minute until doors close for storms on stage. Come on down.
And yet they did add some extra bones here at Death of Barney. I think they did.
You can tell a lot of these are sculpted, especially along
Come
there.
on down. If you see the bears, you're almost there. See a fire vortex. See lightning. Very, very good.
And there we go.
See? Oh, I was right. So science takes a new stance. When scientists mounted this Allosaurus in 1967, they stood it upright. See how it's kind of
Almost like a kangaroo or something like that. Tail on the ground. Its vertebral column kind of shunted up into the air. After all, some modern lizards can walk like this, dragging their tails behind them. Unfortunately, this was probably wrong. Definitely wrong. New research suggests that Allosaurus leaned forward and held its tail straight out like this for balance. Just like I was talking about. And they also have way too many vertebrae in that tail, which is funny. Very cool. Probably stood like this, much more like a bird and less like Godzilla.
Goodness, just close the doors. Goodness. It's so loud. And here we have Camptosaurus.
Lovely display about this critter. Yeah, largest member of its in its environment of the group of dinosaurs called ornithopods. So these will later kind of take over the world as iguanodontians and hadrosaurs. But Camptosaurus is kind of, I don't know.
You could say that it's a sign of things to come. These guys would later be super successful, and Camptosaurus is like, you know, still kind of in beta testing, but pretty successful in the late Jurassic.
I just can't get over how robust those fingers and everything are. Because again, I have a cast of one of these at home, of a Camptosaurus hand, and I bet you we'll see it over here. There it is, right there. Yeah, it's the right hand of Camptosaurus. That is the same exact cast that I have. The carpals and the metacarpals and the phalanges. Yep.
Pretty cool. You also see this at the Los Angeles County Museum and places like that. That cast is pretty common here in North America. Yeah. I've got a lovely crocodile skull here. Another Gavialosuchus, like the big old croc that we saw over there. Very cool. We've got a Haplocamptosaurus tail vertebra. That's neat. That would have been difficult to, or that would have been easy to overlook. I'm glad we spotted it. Haplocamptosaurus, another one of these sauropod dinosaurs from the Morrison that doesn't get enough attention. It's pretty rare. We don't have very many specimens of Haplocamptosaurus. Maybe if we visit Vernal, Utah later in the summer, I'll show you some Haplocamptosaurus material, because they make a big deal about that dinosaur at that museum. Yeah, and this is a big old injury on the animal's tail. So the sign says an injury or some abnormal growth left its mark in this dinosaur's tail. The resulting lump of bony, compacted cartilage by the red arrow there would have been painful but not fatal. So we've got lots of examples of stuff like this, of injuries in dinosaurs. And we call those pathologies. And they can kind of give us interesting clues about how these animals would have lived and behaved. If that's evidence of something that happened to the creature while it was alive. And we can tell it happened while it was alive because there's healing around it. It's not an injury that killed the animal. A little bit. Yeah. And Garios says, are the bills on duck-billed dinosaurs the same material as on ducks? No. Duck-billed dinosaurs, they had a keratin sheath over their bills, like the beak of, like a bird beak. Yeah, not really like the kind of soft. I'm sure duck bills are not actually all that soft, but kind of fleshy like that. No, not on these dinosaurs. It would have actually had like a keratin covering, kind of like your fingernails over the top. And they've been brightly colored too. Here we've got some different dinosaur skulls. Very cool. Including that one. I have this back in my office at home. Dilophosaurus. That's mostly reconstructed. We now know that the skull looks probably a little bit different from that. You should check out Brian Eng's video on Dilophosaurus and what we now know about this animal, thanks to his hard work and the work of people like Adam Marsh. Camarasaurus, we've got one of those in my office too. Mine's a little bit smaller. A little bit more detailed too, shoot. Plateosaurus right here. Man, I'd love to have a Plateosaurus skull to display. A 3D print. Compsognathus, it's another replica. Stegosaurus. These are both sculpts. Actually, Camarasaurus, Dilophosaurus, Compsognathus, and Stegosaurus, those are all sculpts. There's a younger Chasmosaurus right there, or somebody. Doesn't quite look like Chasmosaurus, it's a little strange. Stegosaurus, I've got this one at home as well. And Thescelosaurus, that's not really a proper Thescelosaurus, is it? I don't know. Yeah, and then Edmontosaurus, the biggest dinosaur in the Hell Creek, like we saw at the Geology Museum in Rapid City. And Camptosaurus. There's a mostly sculpted replica right there. Pretty cool. Pretty cool.
Wow, this is pretty stellar.
And Hegpets, what was Brian Eng, E-N-G-H. Check out his video on Dilophosaurus if you're interested in that animal. That'll bring you up to date on the latest science on that critter. Pretty cool stuff. So yeah, and Puppy Crabosaurus, thank you for the 3 months of support. I appreciate you. Yeah, and Zintaus, I said I would lose hours roaming around in a museum like this, and I would enjoy every single second of it. I have been so far, Zintaus. It's been pretty amazing. Let's check out this Diplodocus. We've been walking all around and around this critter so far, and I haven't really talked about it. Holy cow, look at that tail. So this is Diplodocus from the late Jurassic period of North America. This is one of the world's most famous dinosaurs, honestly. It's not quite one of the big 5 or 6, but it's just like one tier below that, maybe. Diplodocus is very well known to the general public. And to us scientists, too. We've got a decent number of specimens of these guys. Pretty extraordinary. Yeah. You can see that little head at the end of that long neck. Those kind of peg-like or even pencil-like teeth. These animals did not chew their food. So those teeth are not for chewing. They're just for basically snipping bits of plants off. And after snipping off those bits of plants, they'd go all the way down the neck, down the gullet, and then into this massive, massive gut region here. Big old stomach and intestines on this critter, and this is really where the magic happens in terms of digestion. Pretty cool. So these animals are basically built to be able to feed very, very efficiently and very quickly. So not having to chew their food would mean that they could ingest tons and tons and tons of plant material really rapidly. And then it all goes down here to the guts, and then just kind of stews and ferments in there. And as they're doing that, they wouldn't actually have to walk around all that much by virtue of having a really long neck. So think about an animal this big and how expensive it would be in terms of calories to be able to walk around a whole bunch. When you're this massive, it's really difficult to move your body around all that much, even if you have a very efficiently built skeleton. So these guys had a trick up their sleeves, and it's that really long neck. By using that long neck, they could kind of sweep it back and forth and cover a really wide arc and just ingest tons and tons of plant material without even having to move their legs at all. They could just stand in one spot and basically sweep in like a 30 or 40 foot wide arc and then just gobble up all of this plant material and then take a few steps and then do the same thing again. A really efficient, energy efficient way of feeding. And that's probably one of the keys to their success. The fact that they didn't chew their food and they had this big long neck allowed them to feed very, very efficiently. And then partly to counterbalance that long neck, and probably also partly for defense, is this super long tail. I mean, look at how small those tail vertebrae get, how narrow they get toward the end of the tail. Pretty extraordinary. So they probably would have used that to kind of thwack at predators who were coming their way. They may have also used it kind of for communication. If a bunch of Diplodocus are kind of grazing, you know, side by side with each other, maybe they could have like kind of reached out with their tails and been like, yeah, hey, I'm over here, don't step on me, that kind of thing. I don't know. But yeah, probably very slow walking animals, maybe Triceratops, although I'm guessing if you were to see these animals walking around in life, you might be surprised at how quickly they move for something this size. I mean, these animals had much of their skeleton is hollow. So those vertebrae that you see there, and the neck and then the tail, if you were to like take a CAT scanner and scan them, you'd be amazed at how hollow they are. So there are air sacs and hollows that run through the vertebrae of these animals, also through their ribs, and even a little bit in their limbs too. So yeah, for an animal this large, it would not be as heavy as you might imagine. And it probably would have been a lot more graceful than you might imagine too in the way that it walked around. Maybe quicker also. So yeah. And there you go, Reno, yes. I would not recommend the whole ingesting plant material without chewing thing like these guys did. You don't have the same gut, biology as a big sauropod. So if any kids are watching at home, don't be like a dinosaur like that. Chew your food because you don't want to choke or give yourself a stomach ache or anything like that. I don't know. If you want to eat your food like a dinosaur, do like a duck-billed dinosaur and thoroughly chew your food. Because duck-billed dinosaurs were very good at chewing. So be good at chewing like a duck-bill and chew your food properly, please, kids. Yeah, very cool. And how fast compared to a Jeep, Gary Oster? Well, I don't know about that, but I can tell you these guys spent a lot less time at the mechanics than a modern Jeep does. I think this dinosaur would be a lot, cheaper to keep on the road than, say, a modern Jeep Cherokee or Wrangler or what have you. Or Renegade. Ugh. Stop asking me about Jeeps, everybody. You know I'm going to have to throw shade. Yeah. Anyway, very, very cool. All right, let's take a look at this mosasaur over here. Right up there. This big ocean-going reptile that lived at the same time as the dinosaurs. So these guys are dinosaur contemporaries, but they are not dinosaurs. A big mosasaur like this is essentially a giant ocean-going lizard. So mosasaurs are they're squamates, so from the same group that lizards belong to. In fact, these guys are probably part of the same group of lizards that Komodo dragons belong to, varanid lizards. So again, just for the sake of clarity, dinosaurs are very obviously not lizards. These guys are not dinosaurs, they are lizards. Mosasaurs were lizards. And they're not dinosaurs. Am I making myself clear? I hope I am. But check out that critter. Very cool. You can even see the sockets for the palatine teeth in there. The teeth aren't actually in the jaw. If you look, so yeah, you've got the teeth along the maxillae and the premax and the dentaries. But look on the roof of the mouth. Do you see those like little holes in there? So those are tooth sockets. So these critters also had teeth on the roof of their mouth as well. And you can see that here in this illustration. There's a mosasaur, and you can see those palatine teeth right in there. And they're in the sockets. The sockets are empty, but that's where the teeth are. How cool is that? These lizards took to the ocean and became perfectly well adapted for an aquatic lifestyle, to the point where they actually more or less gave birth to live young. So it seems like mosasaurs like this were probably what we call ovoviviparous. So anybody who's read a lot about sharks probably knows what I'm talking about already. If you're an aquatic animal, there's a few different ways that you can give birth to your young. You can lay eggs. You can give birth to live young, so just skip the whole egg thing and just have fully developed embryos come out. Or you can kind of split the difference. You can have eggs inside you that hatch inside you, and then the babies swim out, and then the egg, the empty eggshell stuff falls out too. It seems like mosasaurs were probably doing the latter. They were probably ovoviviparous. There was a really cool specimen that was just discovered a couple years ago, just published on in 2020. We actually covered it in one of my earliest streams. But there was this big, weird, soft-shelled egg thing that was discovered in Antarctica. And it seems to have been a mosasaur egg. So these critters, it seems like they had their eggs internally, the eggs hatched inside the mother, and then the young would swim out. So pretty cool, right? Yeah. And there are a ton of ferns right here. Good eyes there's in. Yes. Check out these awesome fossil ferns. Oh, and no, these might not even be true ferns, because Calamites is a giant horsetail, I think. These might predate the first ferns. Yeah, this is Carboniferous coal swamp. Very cool. Yeah. Very neat. Oh, ferns and reeds. Okay, so they are ferns, I guess. Cool. This is from Pennsylvania. This is the original fossils, about 300 million years old. So this is a solid 50 or 60 million years before the first dinosaurs show up. You know, these really cool coal swamps. And just look at some of that material. 300 million years old. Pretty extraordinary. Just beautiful. It's like a work of art. And there, the stem, that's the stem of Calamites, these giant horsetails that grew as tall as trees during the time. Pretty neat. Pretty neat. Yeah. Very cool. Very, very cool. Now with that, shoot, it is almost 1:30 here. I need to go get on the road pretty soon so that I can get to where I'm going. So I'm going to have to go sign off in just a minute. But stick around. We'll go say hello to this big old pterosaur first. There we go. Check that out. Yeah, let's sign off over here. Thank you, Lenina. Holy cow. Yeah. Let's see. Let's see who else is live on Twitch right now. We're trying to hold this at the right angle as I'm using the wrist phone thing. Here we go. Behind me, of course, is this giant pterosaur from the end of the Cretaceous period, Quetzalcoatl. Yes, they really were this big. The last of the pterosaurs and also some of the very biggest. Yeah, let's see who is on right now. Not too many people are on right now. Saturday, shoot. Let us go check out California Burbs. So I will go ahead and go to my channel and chat. There we go. There we go. And it worked. Thank you so much, everybody, for helping make this another really wonderful stream. I had a ton of fun today. I hope you did too. Join me tomorrow. With any luck, I'll be streaming from the Museum of Geology in Madison, Wisconsin. So I've got to go make it there today. So I'm going to go hit the road in just a little bit. Everybody, thank you so much for your ongoing support, your viewership, your enthusiasm, your good questions, and I'll see you soon. But right now, we're going to go tune in to California Burbs, and we'll go see some modern dinosaurs, and make me a little bit homesick looking at California. All right, I'll see you there, everybody. Take care. Bye-bye.